Okay. So we stop at 4.1.2, permutation for n different objects taken R at a time. All right. So we are looking at a permutation at a line. Okay, at a line. So now we are looking at permutation of R objects taken from n different objects in a second. Okay, given by this formula. So NPR over R and 1 over 2 times NPR over R. Okay, R is the number of R, that means R, that is the R objects. Okay, so meaning that if, okay, let's see the example. Is, let's say we have N is 7, then our R is 2, then we use the formula N PR over R, right? Is, so it's 7P2 over 2. Okay, all right. So now we go to if necklace or chain, right? So we use this formula because clockwise, anti-clockwise and clockwise will be treated as the same, right? So meaning that, what do you mean by anti-clockwise and clockwise is treated as the same? That means you flip it over, right? So you reflect over, so it will be the same. Okay, A, determine the number of different ways to arrange 4 letters from the latest flowers. So 4 letters from latest flowers. So we have flowers, the N is 1, 2, 3, 4, 5, 6, 7. Okay, so if you use the formula, it will be 7P 4 over 4. Okay, so if you use another method, okay, or, okay, so 7C4, okay, 7C4, meaning that the 7, the alphabet 7 different letters, we choose 4 first, right? 4 letters. Then we fix 1, okay, fix 1 letters, and then the 3, we will arrange them, 3 factorial, right? So therefore is 1 times 3 factorial. So the answer should be the same, because the relationship between C and P is, okay, so NCR, okay, equivalent to NPR over R. Okay, so NPR over R. So actually is NPR equals to, this one is the same lah. This one is same as NCR. Okay, so the answer should be the same. So let's check 7P4. Okay, 7P4 over 4. So it's 210. 7C4 times 1 times 3 factorial. So also 210. Okay, so the answer, both are 210. So here you haven't learned combination. Combination means we choose only. We don't care what alphabet we get. We choose 4. Okay, and then we arrange the 4 alphabets. Okay, we fix 1, and then the rest we arrange 3, 2, 1. That means this place I can put 3, this 2, and 1. So it's 3 factorial. Okay, so actually it's same as 7P4 over 4. Okay, B, determine the number of ways to arrange 9 person. So N is 9. To sit around R is 4 or 6. So we use the formula, it will be 9P4 over 4. Okay, 9P4 over 4, or we choose first, we choose 4, 9, we choose 4, and then we fix 1 here, and then there are 3, 2, 1, 3 possible, 2 possible, 1. So this is 3 factorial. So times 3 factorial. So you'll get your same answer. So 9P4, okay, divided by 4. So 756, okay. 756. All right. Okay. This one, okay. And then this one is the formula is NCR equals to NPR over R factorial. So let me check the formula. Okay, NCR equals to NPR over R factorial. So actually the same, huh? These two are the same. Okay. Okay. Next. Okay, so you get 9P4 over 4. So it's 756. Okay, so the answer is the same. Okay, C, Nadia can arrange the bracelet. Huh? So this one bracelet means clockwise, anti-clockwise. This is anti-clockwise and clockwise is the same. Okay, so we use this formula. So 7, there are 10 bits we bought. We only use 7. So divide by 7 and then multiply 1 over 2. Okay, so if you use the other method is 10C, we choose 7, 10 times 1 here fixed. So 1, 2, 1, 2, 3, 4, 5, 6, or 6 factorial. Okay, so let me erase this. Right down below. For all, okay, 10, choose 7, multiply 1, fix 1, and then 6 factorial. So 6, and then multiply 1 over 2. So the answer should be the same, right? So 0 0.5 times 10C7 times 6 factorial. So it's 43200, right? 43200, 43,200 ways to sit, okay? If you use 10P7, okay, divide by 7, right, divide by 2, so it's 43200 way to arrange the bits. All right, okay, so B, if six sisters, then is is 9P6 over 6, right? So you should get the answer, okay? Or you can use 9, choose 6, multiply 1, and then 5 factorial, okay? So 1, there are 1, 2, 3, 4, 5. So 5 factorial. So the answer should be the same. Okay, so the answer is here. All right, 10080 and 4200. Okay, so do exercise 4.3, page 1 to 6. So this is question, I think question number 4, right? So you do left one question. Okay, now we go to determine the number of permutation for n objects involving identical objects. So Charlie wants to form a 3 letters password from the word baby without repetition. This all the possible password can be formed by Arif. Okay, so how many password we can form? So we list it down. So we start with BAB. So BAB, then BA, then we have A, B, B. So no more. And if you start with BBY, then it's BYB and YBB. So there are 3 ways, 3 ways. Then ABY, there will be AYB. So if it's fixed B, then it's BAY and BYA. Then we fix Y, so YAB and YBA. So there are 6 here. So total is 12. Okay, so the formula for permutation and object involving identical objects, so is given as P n factorial divided by A factorial, B factorial, C factorial. So this ABC in ABC means how many letters that objects that they can has identical, right? So here is only 2B, right? So we check whether the answer is 12 or not. There are 2 B's, there are 4 letters, so that means P, okay, P equals to 4 factorial divided by 1 pair only, so that is 2B, so 2 factorial. So it's 4 times 3 times 2 factorial over 2 factorial. So you cancel out, you get the answer 12. So correct, right? So the formula correct. All right, so now example 6. Calculate the number of ways to arrange the letters from the word symbiosis in a row and in a circle. Okay, a row and a circle. Symbiosis. So we check how many N first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 letters. So S has how many S? 1, 2, 3. Right? 3 S. I, there are 1, 2, 3 also, 3I. So you want to find out in a row, there are 9, right? So we use 9 factorial over 3 factorial over 3 factorial. So you get the answer 100 at T, 100, 10,080 ways. So if in a circle, okay, in a circle, how? There's a formula, right? In a circle. Okay, so is n minus 1, right? So n minus 1, 1 factorial over a factorial, b factorial, and so on. So this one, okay, we check first. So there are 9. Okay, we fix 1. So they are add more, right? So 1 times 8 factorial divided by 3 factorial and 3 factorial. For circular permutation. This one is called circular permutation. Okay, so 8 factorial divided by 3 factorial, 3 factorial. Okay, so use your calculator, 8 factorial divided by 3 factorial divided by 3 factorial. So you get 1120. So 1120 ways to arrange an object with two identicals, two identicals, right? 3 ways, right? 3 identicals, right? 3 factorial, 3 factorial. So it's 1120. Okay. So A is the number of identical objects. So if there are 2, B, in activity 5, there are 2 B's, so 2 factorial. If there are 3 B's, then 3 factorial. Okay, so this one, 3S, so 3 factorial. I, there are 3, so 3 factorial also. Okay, so now B, calculate the number of ways to arrange 3 mathematical books and 4 identical science books and 5 identical English books in a bookshelf. Bookshelf means we are arranging them in a line. Okay, all right, so there is N is 3 plus 4 plus 5. Okay, so the N will be 7 plus 5, 12. So we are using line permutation. 12 factorial divided by 3 factorial divided by 4 factorial and then 5 factorial. Okay, so if you use a calculator, you should get 27720, 27,720 ways. Then C, calculate the number of ways to arrange 2 red bits and 4 blue bits and 5 green bits to make a beautiful chain. Chain, remember? Chain is anti-clockwise and clockwise is the same. That means you have to time 1 over 2. So we use the formula n minus 1 factorial over a factorial and b factorial and c factorial. So n minus 1. So n is 2 plus 4 plus 5. So 9 plus 2 is 11. So it's 11 factorial over 2 factorial over 4 factorial over 5 factorial. So you get 3, right? And then you multiply half. So you get 3, 4, 6, 5. Okay, so in circle, so remember, we fix 1. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 factorial. Then you divide by 2 identical, 3 identical, and 5 identical, right? Okay. Right, sorry. Oh, so this is 10 factorial, sorry. So this is 10 factorial. So 10 factorial over 2 factorial over 4 factorial and 5 factorial. Okay. So you get the answer 10 factorial divided by 2 factorial divided by 3 factorial divided by 5 factorial. So you get 2520. Okay, so this answer is incorrect. So it's 2520. Okay, so this one is wrong. Huh? Okay, so it should be 2520. This is 10 factorial. Okay, because it's a circular permutation. All right, so let's go to solving problem now. Okay. All right. Calculate how many different 5 digits number can be formed from 8 digits 1, 3, 4, 5, 6, 7, 8, 9 used without repetition. How many of these 5 digits are less than 40,000? Okay. Okay, 1, 3, 4, 5. So what is n? 1, 2, 3, 4, 5, 6, 7, 8. So 8, huh? So 1, 2, 3, 4, 5, 6, 7, 8. So less than 40,000. 40,000. So the first digit must be less than 4, right? That means there are 1 and 3 only. Okay, so this is 1 and 3 only. So there are 2C1, 2 possible ways to fill in the first digit, the first 5 digit. Then we have 4 digit left. Okay, 4 digit left, we can choose from 7, right? 7 P4. So meaning that 7 digit can fill in 7 here, and then 6 here, 5 here, and 4. Therefore, you use 7 P4, right? 2, we choose 1. 1 and 3, we choose 1. and then times 7p4. So that is your answer for number 1. That is 2c1. Okay, so n is 1, 2, 3, 4, 5, 6, 7, 8. So the 8, sorry. So not 9, 5. So is 2 times 7p4. So it's 16800. Okay, so 1680, sorry, the answer. Okay, number 2, even numbers. How many these digits are? 5 digits are even number. So 5 digit. The last is even. Even can be, here can be filled in 4 or 6 or 8. So there are 3 possible ways. The rest will be, so there are 8 digits at all digit 8. So there are 7 left, so 7 P4 times 3C1. So you get your answer. 3C1 is actually 3 lah. So usually I drag down 3, then times 3 times 7 P4. Therefore, you get 2520. Okay. So beside this, there is one more question. Calculate how many different 5 digits number can be formed with 8 digits. So this question usually is a one bonus question. That means we just substitute 9p5. Okay, so 9p5. So you get 15120. Okay, this is also your maximum number you can get. So you can check whether your answer is correct or not. If your answer is 16802520 is less than 15120, maybe it's correct. But your answer is more than 15120, therefore is, of course, is incorrect. Okay. Right. Then we go to B. Okay. Find the number of permutation of all letters in the word history. So you can check. The first thing is whether there is a repeated alphabet or not. History H1, 2, 3, 4, 5, 6. Okay. So is, why I always counted wrongly? 1, 2, 3, 4, 5, 6, 7. Find the numbers of this permutation in which the letters O and R are together. O and R together. Okay. So O and R together. That means O and R, we can consider them together. But O and R can be RO, remember? Okay. If O and R is together, therefore our N now is only 5. Okay. So that means HISTY. 1, 2, 3, 4, 5, 6. Okay, let me check again. 1, 2, 3, 4, 5, 6, 7. Why this is 7. Sorry. I always counted wrongly today. Okay. All right. So now we do the permutation. So the permutation is, okay, 5 factorial, and then you times 2 factorial. 2 factorial, 5 factorial means 1, 2, 3, 4, 5. Sorry, 6 factorial. So this one is 6 factorial. Okay, 6 factorial means represent HISTYOR. 6 factorial. Then 2 factorial is OR and RO. Can be terbalik. That means is 6 factorial times 2 factorial. Or 2, right? 2 factorial. So use your calculator. Times 6 factorial. So you get 1440, right? 1440. Then number 2, if the O and R are not together, so there are 2 ways to solve. One is, okay, find the number of permutation. Okay, so this one is That means it's 7 factorial. So this is 5040. I said there are two methods. So first method is the total permutation 5040 minus number 1. That is the OR is together. That is 1440 equals to 5040 minus 1440. So you get 3600 or 3600. Or you can use another way, that is O and R cannot be together, then that means we have to list down HI, S, T, R, Y. Okay, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2. Oke. Oke, maafkan saya hari ini. Tak tahu kenapa saya selalu silap. Okay, so it's 1, 2, 3, 4, 5. So the O can be here, right? So this place I use red or yellow lah. Here, between, in front of H, in between H and I, or between I and S, between S and T, between T and Y, and after Y. So meaning that if O is here, then R is here. So they are not together. Okay, so therefore the formula for this, how many place here? 1, 2, 3, 4, 5, 6. So we only choose 2, right? So it's 6p2 times 1, 2, 3, 4, 5. The 5 letters we can arrange accordingly, meaning that the arrangement is very important. So we should get 36,000. So it's 6p2 times 5 factorial. So you get 3600. So correct, right? Okay, besides that, we can use, we choose, we cannot choose also, you just use this formula, right? So this is, there are two ways, okay? So first way, 5040, okay, the total permutation without any condition minus the 2 OR it is together, right? Then you get O and R not together, okay? Or you can use this method to find out O and R not together. Okay, C, 4 boys and 5 girls are to form in a line, not a circle line. In how many ways this can be done? Okay, so the first thing is a bonus. So 4 boys plus 5 girls, so you have 9. So n is 9. So it's 9 factorial. So 9 factorial, you is 362 at 0. 362 at 0. Okay, number 1. The first two girls are girls. So the first two are girls. So the girls must be in front. So how many ways we can put here? So there are 5 P2, correct? 5 girls, we choose 2. We arrange them, 5 P2. And then left 7. Okay, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 7 factorial. So 5p2 times 7 factorial. Okay, so you get 5p2 times 7 factorial. So it's 100. So or you can, what you do? Okay, we choose, right? We choose 2 girls, right? We choose 2 girls and then we arrange them. So 5c2 times 2 factorial. So it's the same. 5c2 times 2 factorial. So it's 5p2 lah. Okay, or we choose the girl first, then we arrange the 2 girls. Then we arrange the 7 including boys and girls. So it's the same, okay? So let me check. Pi C2 times 2 factorial times 5 factorial. Oops. C2. Okay. Time. Okay, 100 correct, huh? Okay, number 2. Okay, boy, one boy. Then this one is 7, right? 7. This is girl. So it will be same thing. 4, we choose 1, 4 choose 1, and 5 choose 1 girl. And then in the middle is 7 factorial. So you get your answer. 4P1 and 4C1 is the same, huh? So because you get the same answer. So 4 times 5 times 7 factorial. So you get 100 0 also. Okay, so C2, correct. Then 3, the boys are together. The boys are together, that means the girls also, the boys are together. The boys are together. All right, number 3. Okay, so the boys are together. Okay, let me rub off here. Okay, the boys are together. So the boys are together, that means left the girls, right? So the boys, number 3. So the 4 boys are together. 4 boys and 5 girls. 1, 2, 3, 4, 5. Girl, 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 girl. Okay. So that means the 4 factorial, the boys can be arranged 4 inside here. 4 factorial ways, and then the total now is n is 6, so it's 4 factorial times 6 factorial. 6 factorial means the 5 girls plus the 4 boys together. Okay, so we can arrange them: girl, 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 boys, or girl, 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 boys, girl. Okay, and then 4 factorial means the arrangement inside the boys, inside the 4 boys. So it can be 4, 3, 2, 1. The first place there are 4 person can fill in, and 3, 2, 1 like that. So it's number 3. So the answer is 4 factorial times 6 factorial. Okay. That's 17280. 17280. Number 3, number 4. Okay. Number 4 is no girls stand next to each other. No girls stand next to each other. So the girls must be separated. So must be separated. So the only way is girl, 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 and then the boy is between. Okay, the boy is between. So the boy is here. Okay, so the only solution is, okay, this fixed, right? That means the girls is 5 factorial times the boys is 4 factorial. So 5 factorial times 4 factorial. So you get 2 at 0. Okay, so the last one is, okay, let me rub off this. Okay, the last one is no boys can stand together. No boys can stand together. So there is 2 ways to do it. First way is the total 9 factorial. You minus the boys together. That is number 3. That is 4 factorial and 6 factorial. So is 362 at 0 minus 172 at 0. Okay, 362 at 0, 362 at 0 minus 172 at 0. So you get 345600. 345600. Or the girls, you stand like this. The girls. Okay, and then the boys can stand here. 1, 2, 3, 4, 5, 6. So therefore, the sixth place here, we choose 5. So 6p5 multiply 5 factorial. Okay, let's see. 6p5 times 5 factorial. Oops. Go on. Okay, now 1, 2, 3, 4, 5, 6. One, two, three, four, 6. Okay, wrong again. 6p4 because there are only four boys. Okay, so 6p4 times 5 factorial. So we get 4, 3, 2, 0, 0. Okay, let me check what is it, why is different. So 0, 0. Okay. No two boys can stand together. The girls say, okay, 1, 2, 3, 4, 5. Boys, 6. 2, 3, 4, 5, 6. Choose 4. And then the girls, 3. Okay, let me check. I'm not sure what happened. So it's 43200, and this one is different. The boys are together. Mm. Three, 4, 5, 6. Okay. There's a difference here because it should be the same answer. Alright, the boys are together. The boys are together. No two boys are together. Okay, sorry. So we cannot use this method, right? So this method cannot be used because this method is only four, not four together. Okay, it can be 2 together, 3 together, 4 together, right? Or 2 together or 4 together. We have to consider, if you want to use this, we have to consider 2 together, 3 together, and 4 together. Right? This is 4 together. The boys are 4 together. So you have to consider 2 together. The 2 boys are together, and then the 3 boys are together. So this is the best way to solve it. Okay, so we cannot use this method. So highlight this as blue, cannot use. This one cannot use this method to find no two boys can stand together. Okay, because we minus 9 factorial minus 4 factorial 6 factorial is only for, we only minus deduct the boys, the 4 boys are together. How about the 3 boys are together? and 2 boys are together, right? 2 boys and 3 boys together, that means, or 4 boys together, right? So that one we did not consider in this solution. So the best way is we list down the girls together, the girls separate, and then there are 6 space between the girls that the boys can stand, and then we do 6p4, right? And then 6p4, that means the boys can be stand here 1, 2, 3, 4, or 1, 2, 3, 4. Okay, so there are 6 space for the boys to stand. Okay, all right, so number 5, so I hope you understand. Then we go to D. D is calculate how many different ways 5% can stand in a row from 4 boys and 5 girls. Okay, 4 boys and 5 girls. So again, 4 boys is 9 factorial. So you get 362, 8, 8, 0. Okay. Okay, B number 1. Exactly 2 boys. Okay, so there are 5, right? Okay, so if, okay, sorry. This is if no condition. The 9 must be standing in a line. But now there are how many ways? 5%. Okay, so there is 9p5. If no condition, 9p5. Okay, so you get 15120. Okay, all right. Then there are exactly 2 boys only. So 2 boys. Okay, 2 boys. That means we have to choose. Okay, 3. Sorry. Okay, we have to choose the 4. 4. Choose 2. Okay, 2 boys. And then the girls, we also choose 5, choose 3. Then the 5% we choose, we have to arrange them 5 factorial. Okay, so is all right. So is 4c2 5c3 times 5 factorial. So it's 7200. Okay. So if we use 5p2 and 4p2 and 5p3, so you need times 5 enough. Huh? This means 4p2 times 5p2 times 5, you get choose 2, choose 3, and then the 5%, we permute them. Huh? If you use 4p2 and 5p3, okay. Okay, so you get 7200 only. All right, but here because exactly 2 boys, that means 2 boys and 3 girls. So we choose 2 boys first, and then 5 girls. We choose 3 girls from the 5, and then after that we arrange them in 5 factorial. Okay. Number 2, so we cannot use 4p2 times 5p2, 5p3, because 4p2 and 5p3 means we already fix it like this. This is the 2 boys and 3 girls. Then you can use 4p2, 5p3, but they still can arrange among themselves. Okay, among themselves. So meaning that the boys can sit here like that. Okay. Okay, the boys can, maybe the boys, girl, boy, girl, girl, like that. Okay, so it still can arrange among themselves. So if you use this 5p2, and then you have to use 5 factorial times, I think 2 factorial over 3 factorial. Okay, all right, so don't use this. Okay, 5p2, this is not the correct answer. Okay, the first is boy and the last is boy. So the first and the last, this is fixed. Therefore, you can choose, this is 5p, sorry, not 5p, 4p. So here is 4p1. Then here is 3p1. Okay. So, or you can use 5p2. Okay. So here is 3. So it's 5p3. Okay. Or you can use 5p2 times, not 5p2, 4p2. This one is fixed, so you can do like that. 4p2 and 5p3. Okay. Then you get your answer, 4p2, 5p3. So you get 720. Do you see it? So you can arrange them many places, right? Therefore, this only one solution. If you use this one only solution, but it's 720, that means there are 10 different ways you can rotate them, right? Okay, if more boys than girls, the boys more than the girls, that's mean if only 5, there are only 4 boys, right? So that means it's 3 boys, 2 girls, or 4 boys, 1 girl. So here we have to choose the 4, choose 3 boys, and then the 5 choose 2 girls, and then 5 factorial. Then you arrange them. Then you have to plus the 4 boys. We choose 4, and then we choose 1 girl, multiply 5 factorial. Okay. So this one. Okay. So you get 5400. Okay. Right. This is number 3. Number 4, more boys and the more girls than the boys, and the girl must stand together. So more boys than the girl. So 3 girls, 2 boys, 4 girls, 1 boy, and 5 girls. Okay, you can see here, if three girls, so 5c4. Sorry, 5c3, right? 5c3 times 4c2, and all right. So here you'll be a bit confusing already. So there are 3 girls and 2 boys. Okay, so here we need to choose, right? We choose the 5, choose 3, and then the 3 have to rotate, right? And then here we choose 4, we choose 2. That's all is 4c2. This one 5c3 is here. And then the 3 here we have to arrange the 3 again, right? So boy, boy, girl, girl, boy, boy, girls, boy, boy, or girl, boy, girls, boy, or boys, boy, girl, right? Boy, boy, girls. Okay, so you have 2160. If the 4 girls are together with 1 boy, so that means 4, 1. So 4 boys, 4 girls, sorry, 1 boy. So we still need to choose, right? So here we choose 5c4 times 4 factorial. So inside we arrange. Here is only 1, that is 4c1. Okay. And then we times 2 factorial. Why 2 factorial? These 2 can change. Boy, girls, girl, boys. Okay, 2 factorial. So it's 960. The last one, the 5 girls. So 5 girls, no boys, 0 boys. So 5 girls together, no? That means 5 factorial, 120. So you add all this together is 3240. Okay, so make sure lah. So make sure is 5c2 is 5p2, 5p4 times 4 factorial times 2, right? 4c4 times so it's 960, correct? Okay. Let me check for one. Okay, so hopefully I won't make you busy. Yeah. Next one is there are 3 boys and 4 girls. How many ways to arrange them in 5-seater round tables? So 5-seater round table. So first thing, we need to choose the 7, the total 7, right, person. We have to choose 5. Okay, choose 5. That means choose 5 and then after that we arrange them. After we choose 5 and then we arrange them. So that is phase 7C5. 3 boys and 4 girls, we choose 5. We don't care about the gender, and then we arrange them. Picks 1, we arrange the rest 4 factorial. Therefore, it's 7C5 times 4 factorial for no condition. How many ways to arrange them? No condition, right? So 7C5 times 4 factorial. Okay, 504. Okay, this one is 504 or C4. Okay, 7C5 times 4 factorial. Okay, 504. Okay, and factorial. Right. Okay, so it's 504. Okay, so now we go to the second one. There are exactly 2 boys. So 2 boys, we need to choose 3, choose 2 boys, and then the girls have left 3. So 3 choose 2, 4 choose 3. Okay, so this is for boys. This is for girls. 4 choose 3 choose 2. Okay, 3 choose the boys, 2 boys, and 3 girls we choose from 4 girls. So 4 choose, and then the 4 factorial. So fix 1 and then 4 factorial. So that is your answer lah. Okay, 3C2 times 4C3 times 5, sorry, times 4 factorial. So it's 2 and 8. Okay, sorry, 2 and 8 here. Next one, if there are exactly 2 boys and must sit apart, sit apart. Okay, sit apart. Okay, so it make me more difficult. Choose 2 boys. Okay, 3C2. Okay, okay. And then the 2 boys must sit apart. So that means there are, okay, I put here. They must sit apart. That means the 3 girls. So I choose 1, 2, 3. So I choose 1 girl. The 2 factorial. 2 can either this way or this way. Okay. And then the boys can sit in between. So 3 factorial. Okay. 3P2 times 2 factorial. Okay. So it's 3C2 times 4C3 times 2 factorial times okay, sit together. Therefore, this one I cannot use 4 factorial, but I have to use 3P2. Okay. So you will get your answer. 3C2 times 4C3 times 2 factorial times 3P2. So it's 144. Okay, 144. Okay. Now number 3, at least 3 girls. 3 girls, that's mean 3 girls and 2 boys and 4 girls and 1 boy. Cannot, there is no 5 boys, 5 girls. So that means we have only 2. So therefore it's 4, 3C, 3C2. Okay, 4 choose 3 girls, 3 choose 2 boys and 4 factorial. Okay, and then plus 3 choose 1 boy, 4 choose 4 girls, and then 4 factorial. So you add up this one, these 2. Okay, so you get the answer lah, 4C3 times 3C2 times 4 factorial plus 3 choose 1 times 4 choose 4 times 4 factorial. So you get 360 only. Okay. Okay, we can check the answer because we cannot more than 504. Okay, so the other way to do number 2 is we minus the 2 boys together. So that's mean the 2 boys and then the 3 girls. Okay, so this 3 factorial times 2 factorial. Okay, times 4C2, sorry, 4C3 times 3C2. Okay, let me check, correct or not. C3 times 3 factorial times 2 factorial. So it's 144, you minus 504, so you get 360. Okay, but the question, the answer is different. Huh? Let me think. 3C2 C2 times C3 times 3 factorial times 2 factorial. Okay, 144, 560 minus 144. So you get 360. So it should be 360 here. Okay, let me check why. Two takes the girl. Left 3, 1, 2, 3. So 3p2 times 2 factorial. Okay, so never mind. I will check again. Number 2 and this solution. When I choose 57C5 times 4 factorial. Okay, minus the boys, exactly 2 boys, and they sit together. Okay, should be the same. All right, so it's 3 factorial, 2 factorial, boys, 3 girls, 6 factorial, 2 factorial, 3 choose 2 times 3 choose 2, 4 choose 3. So it's 360 and different. The answer is, this one is 144, this one is 360. So never mind. Later on I will figure out. Okay, F, find the number of possible ways, okay, to arrange all the letters in the word tranquility. Okay, tranquility in a circle and a row and in a circle. Tranquility, T, R, A, N, Q, okay, 1, 2, 3, 4, U, then I, L, T, there are 2T, and Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So 11. So if you arrange them in a row, therefore is 11 factorial divided by 2 factorial, 2 factorial for line, in a line. Okay, because this even factorial, there are 2T and 2I. So there are 2 factorial, 2 factorial. Okay. So 11 factorial. Okay, hold on. Okay, divided by 2 factorial, divided by 2 factorial. So you get 9, or a big number, 79200. So if in a circle, okay, the vowels must be together. Sorry about that. Vowels must be together. Okay. Then this one is no condition. This one got condition. The vowels must be together. So that means A, U, I must be together. So A, U, I must be together. Okay, 1, 2, 3, 4. Therefore, the rest 1, 2, 3, 4, 5, 6, 7. Okay, so therefore is 4 factorial times 8 factorial divided by 2 factorial divided by 2 factorial. So this is should be the answer. Okay, 4 factorial times 8 factorial divided by 2 divided by 2. So it's T241920. Okay, 241920. Okay, if the AUII together, the vowels together, and TT, R, N, Q, L, and Y. So 1, 2, 3, 4, 5, 6, 7. So 7 plus 1. So 8 factorial. So arrange, and then the 4 arrange, and then you divide by TT together. TT repeated, right? And then 2 II repeated. So 2 factorial, 2 factorial. So you get 241920. Okay. All right. So next is we arrange them in round table. So round table. Okay, round table. So I choose the vowels together. Okay, and then the rest will be 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. Okay, so here is 7 factorial times 4 factorial. Then you divide by 2 factorial, divide by 2 factorial. Okay, so you get the answer. 7 factorial times 4 factorial divided by 2 divided by 2. So it's 30240. Okay, 30240. Okay, so that is your answer for if the word tranquility is arranged and the vowels are together. Okay, all right, so please do the exercise 4.5, self exercise 4.5, and also self exercise 4.4 and 4.3, question number 4. Okay, so anything, please ask. Okay, so